Across the globe, hundreds of thousands of Arduinos are controlled by potentiometers, mindlessly obeying their will. These poor souls have no say in what values they will be presented on their analog inputs. But today, Arduino fights back. Today, Arduino will control the potentiometer with the help of a tiny chip called X9C103S, also known as digital potentiometer. Welcome back! So what is this chip and how are we going to use it? Let's take a look. This thing has 8 pins, a power supply between VCC and VSS, 3 control inputs, and we have 3 potentiometer pins, 2 ends and 1 wiper. This thing has no mechanical parts inside. How does this work? So we have 99 resistors and 100 wire tap points. As soon as a transistor turns on, it connects this wiper tap point to the external pin. And using these control inputs, you can now control which part of the resistor network will be connected to your wiper pin. Also, very important, we have a non-volatile memory inside. So even if you remove the power, this thing still remembers its last state. Just like your mechanical potentiometer. It should be possible to measure the resistance between this pin and this pin. I have the X9C103, so it should be around 10 kilo ohm. However, these chips come with an end-to-end resistance of plus minus 20%. 10 kilo ohm would be perfect, but it should be somewhere between 8 and 12. I have 9.5. What do you think will happen if I measure the resistance between one end and the wiper? Think about it for a second. 2.7 mega ohm, so it's not really connected because we have no power supply. Unlike your traditional potentiometer, this one requires a power supply to connect the wiper to your resistor network because the transistor needs to be turned on, and that requires gate voltage. And this also brings me to an interesting point. In this diagram, it's not clear if it's an N channel or a P channel MOSFET, but my guess is it's an N channel. In order to turn it on, you need a positive voltage between source and gate. So gate needs to be above source. This in turn would limit the voltage because as soon as you would connect a voltage to the wiper that is 5 volts, you need a voltage higher than 5 volt to turn on the transistor inside of this transfer gates. And they don't tell you much about it, but there is a small hint, and that is this paragraph. So the internal charge pump allows a wide range of voltages from minus 5 volts up to 5 volts. So this chip creates a voltage higher than the supply voltage, so you can connect any of these potentiometer pins to any voltage between minus 5 and plus 5 volts. Now this charge pump operates at the frequency of 850 kilohertz, so it creates a little bit of noise in this frequency range. One very important thing to keep in mind is the very limited power rating of this device. We only have 10 milliwatts, so try not to push it too hard. The resistors of this resistor array are very, very tiny. If you want to power anything serious with it, you need an amplifier. As already mentioned, we have 3 inputs, a low active chip select, a low active increment, and up or down selection. So if it's high, then it's up, and if it's low, then it's down. Also, one thing to note is it's not possible to read out the value of this potentiometer. So in most applications, Arduino will have to remember the state of the digital potentiometer. And this should also be non-volatile, so we should store it inside of our EEPROM probably. If you would like to play around with one of these yourself, you can find a link to this product in the video description. The next step is to connect it to my Arduino Uno. In order to connect this chip to my Arduino, I will solder it to a PCB and then put it onto a breadboard. I already made a video about this process, so you can check it out if you're interested. If you like your breadboard, don't do the next thing. My breadboard is already very disgusting, so I will just put it in there. But this of course damages the breadboard, so don't do this on your new shiny breadboard. Let's connect them. Ground on pin 4, 5 volt supply voltage on pin 8. Now the potentiometer should actually start working. The charging pump should work inside, and it should actually turn on a transistor inside. So let's see if that happens. If I measure between Viper and low, I see a resistance of 9.5 kilo ohm. And if I go between Viper and high, it looks like the Viper is at the very top. 20 ohm is the Viper resistance. The typical Viper resistance is 40 ohm. I measure 22, that's perfect. So we are at the very top. In order to control our digital potentiometer, we need to connect these 3 pins. Let's connect increment to pin 10. Const int increment pin 10. Const int up down pin is pin 9. Chip select pin is pin 8. We will also connect the output to an analog pin so that we can measure what is going on. I will connect the top of the resistor array to 5 volts and the bottom of the resistor array on pin 6 will be connected to VSS, so ground. So now it acts as voltage divider between ground and 5 volts, and we can get this voltage on the Viper pin, and I will connect it to analog input 0. Now how can we use this? Oh, I need to fix that microphone. One way of doing it would be to code it ourselves. However, I'm pretty sure someone already used this potentiometer, and so I will search for libraries. That looks pretty good. Let's install the very first one. digipot. And usually it comes with examples. Okay, very simple. Let's copy everything that we need. We include this library. We initialize a digipot object with increment pin, up down pin, chip select pin. We also need a serial connection. And then inside of my loop, actually it's a pretty good idea to do exactly that. But I will also add the analog readings, of course. Let's do serial.print A0 equals, and then serial.print analog read A0. So now I should see the increase and the decrease. All right, this looks great. So we're increasing. And then we're decreasing again. Perfect. It's exactly what we expect. We can also measure the output voltage between ground. I take it from here and pin 5. As you can see, the voltage is increasing up to 5 volts. And then it's decreasing again. However, the problem is Arduino doesn't remember. We increase to the maximum and then I press restart. Then it starts again. As you can see, it's now increasing and nothing happens on the output because it's already at the top. Now, if it doesn't matter in your application, this is also one way of catching up with the potentiometer. And that is, if the Arduino starts, you just increase it 100 times, and then you're sure that you are at the top. In fact, you can increase it 99 times. But of course, it's not always possible to just increase it. It depends on the application. But this is pretty boring. Right now, we're just going up and down. I would like to control it. I would like to tell my Arduino, jump to 20, enter, and then it should jump to 20. How can we do that? Well, first we need serial read. It looks like this. We need a string object called input string, and it's empty at the beginning and it's not complete at the beginning. And then we reserve a number of bytes for this input string. 200 is a lot, so we will not need 200. So let's copy the string. We need to reserve some memory. 200 is a lot. I would use maybe 20. So then inside of a loop, we check if the string is complete. And if the string is complete, then we do something and then we set it to false again. So we will not print, we can print it. Yeah, we can also print it. Let's copy it. Can also print it. I will remove this for now and add this stuff here. If the string is complete, I will output the string, and string complete is then false, and we can capture a new string. And this stuff right here we can use exactly as it is. Every time Arduino gets serial data, a serial event is called, and you can define it if you want to. So in this case, it checks if serial data is available, and then it reads the next character and it adds it to its input string. And if there is a \n, that signals the end of the line, then the string is complete. So let's see what happens. Hello. Hello. Okay. Yeah, very nice of you, Arduino. How are you? Now, as you can see, it just replies the same thing that I sent, of course, because that's all I do here. We can now use this to control our potentiometer. So first we need to convert it to an integer. Int target value equals, how can I convert a string into an int? Not to int. And we can see if it works by printing the target value as decimal number. Let's see. So I have a press 111, 111. Hello, 0. Okay, so if I put 1H1, it's 1. If I say 1H8, it's 1. 173, 17. Okay, so it takes whatever number comes first, and if I say E2, E4, it's 0. Okay, so if it starts with a number, it takes the number, and else it's 0. Okay, the great thing is I enter the number and it converts the number into an integer. How can we now move to this target? We need to increase it if our target is higher, and we need to decrease it if our target is lower. How do we know if the target is higher or lower? We need a new variable. Let's create a new variable. Pot value equals 0, because we will start at 0. And to be sure that the potentiometer is also at 0, we need this code inside of our setup. Of course, we can increase the speed. And we can say decrease potentiometer to 0. So now inside of our setup, we decrease it 100 times, we set it to 0, and then we know that the pot value is actually the true pot value. Because you never know, we can't read it. And then let's do something like this. While target value is not pot value, if target value is bigger than pot value. So if the target is bigger than the pot value, we need to increase. And we do it like, no, like this. And else we decrease. So this would be one way of doing it, or we input the number. This would also work. So, because if we do it like this, we need a while loop. So while we're not exactly there, we increase, 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 or we do something else. We can also, if target value is bigger than pot value, we increase it by the difference. And we do it the other way around. But we need to check if it's actually smaller, because maybe it's the same. Let's keep this in our loop and add a small delay of 100. Yeah, we need a new line here. A0 is 0. So we start at 0. That's great. And now I would like to set it to 20 and it's set to 200. So if I go to 100, I go to the top. 50 is... Okay, decreasing doesn't work. Let's debug this. Okay, so I can increase the value to up to 100, but I can't decrease it because it doesn't jump into it. Interesting. My target value is 50, but this is not triggered. Because we need to update the pot value. So after this, we can say with confidence, pot value equals target value. 100, boom. 50, oh yes. 100, 0. That's how it should work. Okay, we can remove this debug information here. And this is exactly how it works. Awesome. So now the potentiometer is at 1023. And if we restart it, it goes to 0. And by the way, we don't really need this for loop here. We can also decrease it 99 times. So we don't need this. So now we're at 0. I go to 100 and I restart my Arduino. And we jump to 0. Yeah, that works. The last step is to utilize the EEPROM. So let's also utilize the EEPROM. We go to examples, EEPROM, Now the EEPROM is the non-volatile memory that you can use in your Arduino, and every time I change the value of my potentiometer, I would save it to the EEPROM. So let's check EEPROM read. So first thing, we need to include the EEPROM library, and then we read the value. Pot value equals EEPROM read. Let's use address 0. One issue is that right now there is something inside of my EEPROM, and most likely it doesn't correspond with whatever is stored inside of the potentiometer. So for the very first time, I will also set this to 0. Let's go to examples, EEPROM write. So just for the very first time, address 0, value 0, and now the potentiometer is set to 0, and the EEPROM is also set to 0. And now we can remove the write, and we can also remove the decrease. So from now on, I just read back whatever is stored inside of my EEPROM. And inside of this, we will store the new pot value inside of our EEPROM as well. One last thing, we need to check if the input is valid. If target value is bigger or equal to 0 and target value is smaller or equal 100, then we do all of this stuff here. Let's try this. All right, so if you set it to 0, it will go to 0. If you set it to 100, it goes to 100. And if you restart it, it stays at around 100. I think it jumps down by 1. Interesting. Oh. Every time I restart it, it jumps down just a tiny bit. That's not good. Why? So maybe this, yeah, okay, makes sense. The maximum amount is 99 because 0 is also one value. Yeah, okay. Makes sense. So it should be between 0 and 99 actually. This makes sense. Yeah, let's go to 0 and now go to 99. Yeah, and now we're at the max. 0, 99 is the maximum. 50 is somewhere in between. Yeah, a little bit higher. Now I think it's perfect, but let's see if it stays now. No. Okay, if I reset it, it still goes down. It's probably the pins that are toggling. Chip select is low at the very beginning, so it should be possible to fix this by using a pull-up resistor on the chip select. Now I put in a pull-up resistor. Let's see if that helps. Still decreasing. That's a tragedy. Let's check the library. Open folder, documents, Arduino, libraries, this stuff right here. Do I trust? Yeah, okay. They're setting it. Yeah, they are defining it as output and then they're setting it high. So it's decreasing right here. That's not good. We need to change this. Yes! Okay. If you want to store the value inside of your EEPROM, don't use this library because this has a bug, obviously. Or fix it. Yeah, you can fix it by putting digital right before setting it as output, because then chip select stays high. Otherwise, it is low for a very short amount of time, and that decreases the value. But to be sure, I would also add a pull-up resistor on the chip select line. As soon as you press the reset button, Arduino gets unconscious and releases all its outputs. So the chip select pin will just float around, which is not great. It might trigger the increment, unless there is a pull-up resistor already inside, maybe. Nope. Okay, there is no pull-up resistor. Definitely add this 10 kilo ohm pull-up resistor between 5 volts and the chip select line. That helps. Let me try one last thing. I would like to connect the low end to 5 volts and the high end to 0 volt. It should also work. Or it just dies. Let's see. So this is the high end. I will connect it to ground. All right. Looks good. And now everything should be inverted. If I go to 99, sorry. And 0 is now the maximum. 99 is the minimum. And if we go to 50, we're somewhere in between. And 99, 0. Yeah, that also works. And the microphone is already coming into the picture again. If this video was helpful, please like and subscribe to this channel. And if you would like to see a real-world application of a digital potentiometer, check out my ESP32 Power over Ethernet project. Did you already use digital potentiometers in the past? Which one? Let me know in the comments down below. Thank you for watching. See you in the next video.